Okay, so another thing for coupling to occur, because remember we did excitation contraction coupling, which ends with actin and myosin binding together. But what you didn't see before that occurring was the fact that myosin had to have had bound to it fresh adenosine triphosphate for it to be able to couple to actin. So adenosine triphosphate and calcium are required for excitation contraction coupling. That's an important concept to understand. Once adenosine triphosphate has been bound to that myosin head, it will undergo hydrolysis, and that splits it into adenosine diphosphate and inorganic phosphate. Now the myosin head is energized, and it can bind to actin. It's also separate from actin. It can't bind to actin if it's already stuck to it. So here we have an energized cocked, this is what they call cocking of the myosin head. It's ready to join to the actin. And again, once that troponin pulls tropomyosin out of the way, now we can have actin and myosin interact by forming a cross bridge. Now, when these two bind together, that bond causes a change in this portion of the myosin protein, releasing phosphate. So phosphate gets released first. That causes an even stronger bond between these two guys. And that also, again, when you release bonds, that energy of releasing the inorganic phosphate is what's going to allow that power stroke to occur. And the power stroke is going to pull the actin filament inward. And when that happens, that's when the adenosine diphosphate gets released. Now, I'm actually splitting it up. You don't really need to know which gets released first, but I thought I'd explain it in the same detail that the video did. So, there's your power stroke. We're moving actin inward towards the middle of the sarcomere. And again, the actin and myosin can only be broken apart with fresh adenosine triphosphate. When fresh adenosine triphosphate binds to the myosin head, it breaks that bond between actin and myosin. Okay? And then we're ready to go again through this repeating cycle.